Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over ionic and net ionic equations for weak and strong acids. And so they're a little bit different, and so I want to make sure that you understand the difference between these. Um, so here we have a strong acid, and again the difference between a strong acid and a weak acid is that the strong acid is going to ionize completely in water. So when you react your HCl with NaOH, the HCl and the NaOH are completely ionized, completely or dissociated if we have an ionic substance. And so then these two are going to come together, right? So we have our NaCl that's going to come together, and you have your hydrogen and your hydroxide are going to come together to form water. And so when we write the complete ionic equation, these are going to be separated. So if we write the complete ionic equation, it will look like this. So you have your H plus aqueous plus your Cl minus aqueous. So that's separated, plus your Na plus aqueous plus your hydroxide ion aqueous. So your reactants are completely dissociated in water, right? So then you do the same thing with your products. Your water is a liquid, so you keep that together. It's not an aqueous solution, so you keep it a liquid. Everything stays together. And then here we have aqueous, so you're going to break that apart into the ions. So sodium is aqueous plus your chloride ion is aqueous. Okay, so this is your complete ionic equation. The strong acid is separated into its ions, and the strong base is separated into its ions. And then when you write the net ionic equation, you're going to get rid of everything that doesn't react, and the ions that are just floating around in solution, you're gonna get rid of those. So the hydroxide and the hydrogen form the water, so you're going to keep those. The rest, your chloride ions and your sodium ions, are your spectator ions. So those are going to remove. So you have H plus aqueous plus your OH minus aqueous, and that's going to go to water, liquid water. Okay, and so that is your net ionic equation. Okay, so this is your molecular, so your balanced molecular equation. This is your complete ionic equation, and this is your net ionic equation. All right, well, what about a weak acid? How do you do that? Well, to write the complete ionic equation, you are, again, going to separate the ions into separate ions. You're going to separate your substance into separate ions. But the thing you have to remember is that your weak acid doesn't separate very much. It hardly separates. I mean, a tiny, tiny, tiny fraction is going to separate. So it's literally most of it is going to be in this form. So when we write our complete ionic equation, we don't separate HF. So HF is going to stay together even though it's aqueous. And so most of it, a huge majority of your HF is floating around in this form together. So the hydrogen and fluorine are bonded together, floating around. So it's dissolved in this form. There's a tiny, tiny fraction that's going to, where it's going to separate and ionize into ions. So we keep it in this form. Now this is a strong base. The base, this is a salt, ionic substance. It's going to dissolve. So this is going to separate. So we separate the Na. So this is going to be sodium plus aqueous plus OH minus aqueous. And then the water is going to come together. Now some of this is going to separate. So you will get some hydrogen coming to join with the hydroxide. And because this is a strong base, this is going to react with the hydrogen fluoride. So because this is a strong base, the hydroxides are going to react with this and take away the hydrogen. But even though that happens, this is not separating. So the hydroxide ion has to come and take the hydrogen away from the fluorine to react. So you will form water. And then what's left over is you have your fluoride ion. So you're going to have your fluoride ion over here. So you're going to have your fluoride ion and you're going to have your sodium ion as well, plus aqueous. And so that's going to be the ionic equation, the complete ionic equation for this substance. Okay, so where do we go from here? Well, with regard to this, so we're gonna the spectator ions are the ions that stay the same on both sides, right? So this doesn't really change, right? So we don't have HF aqueous on this side. So we're going to keep that. We have sodium on both sides. So this sodium aqueous and sodium aqueous, we have it on both sides. So we can get rid of that. That's going to be a spectator ion. The hydroxide ion is going to combine with hydrogen to form that. So that's going to be part of the reaction. So we're going to keep that, keep the water, and the fluoride ion is changing here. So then when we write our net ionic equation, we're going to have HF aqueous plus OH minus aqueous, and then that's going to go to H2O liquid plus we'll have the fluoride ion. And so that's going to be your net ionic equation. So the net ionic equation for a weak acid is going to include the weak acid reacting with, in this case, a strong base, so your hydroxide ion, to form water, and then you have your fluoride ion or the anion left over. So that's the difference between the weak and strong acids when we're talking about balanced equations, ionic and net ionic equations. So this one would be your balanced molecular equation. This would be your complete ionic equation, and this would be your net ionic equation. So I hope that was helpful. If you like this video, share the video, like the video, subscribe to the channel, and make a comment in the comment section. Let me know what you think, and ring the notification bell if you want to get notified by any other videos I put out. Thanks for joining me, and I'll see you next time.